Okay, so welcome back. Let's take a look at page 2 of our review. Um, yeah, just jump right on in here. So what we've got here in this particular situation, you can see I've already have a little bit of writing on my page here, but it's asking me to identify the ones that are linear. I had to kind of restart my video for a reason, but see, every time a function is linear, that means my delta y, or my independent variable over delta x, my dependent variable, has to be some kind of a constant, okay? So as I look through these values, I saw that delta x is a constant, which is great, but delta y is certainly not, so it's not linear. Second, I look at this thing and I notice that the delta, again, this is kind of like saying x and y. This one is a constant, but that one is not. So that's not linear. So that means if there is going to be one, it's this one at the bottom. And you can see right away that it is going down by 3. And it is going up by 2. So it looks like my slope is -3/2. Now, what would be smart if I went ahead and just used, again, I personally like to use x and y, but sometimes we have teachers that do things a little bit different than we do, and it's okay to get used to that. So I did y minus 19, x minus 3 with my slope of -3/2. Now, this is actually an acceptable answer in some classes, but not in all. Some people want you to go all the way to slope-intercept. That's actually very typical. So I did a little quick distributive property, and then I added 19 to both sides, which gave me, I believe it's 47/2. You can see I made a little bit of a boo-boo here earlier with a negative sign here. And so we've got this, but honestly, in the first video, I realized I messed up with that negative sign and it screwed it up royal. I caught it because I grabbed my calculator. Just because if we have the time, why the heck not? Let's type that in. And if I go to table set right here, which is blue window, and I put it into ask mode, I can go to my table and I could start typing numbers in and say, hey, calculator, what happens at 3? And I realized right there, I forgot to put that negative in. Let's fix that. So let's go back here to the table. And now all of a sudden 19. Oh, there we go. There we go. And that's actually, in fact, how I figured out that I made a mistake earlier, is that I typed that in and I saw something was wrong. Okay. Now we also are going to be looking for an exponential story. And an exponential story has to be something like a times b to the x, where we're constantly either multiplying or dividing. Technically, they say this one down here has a constant difference, and this one is a constant ratio. So like if you took 24 divided by 6, you get 4, but 6 divided by -4 is not 4. So this one cannot be exponential either. So you can just kind of bail out on this one. We don't need it. It turns out that that one was a quadratic, but I never required you to solve that one. I said, if it's not, you don't have to find it. But this is the one. And I did it on purpose to see that as you go this way, 6 times 4, so clearly this is a quarter. And if you look here, each one of these is in turn a quarter of the one before it. So my value of b right here is 1/4. So we definitely have 1/4 raised to the x power. And I don't need to mess around with the letters, but remember the number in front, a, is my initial condition, which in this case is 384. Now, let's just say for the sake of argument that I didn't give you this and you just had something like 2 comma 24, which totally could happen on the test. And maybe I didn't give you enough context to even backfill. Well, what you could do is you could write down a times 1/4 to the x, and we could just plug in something like 2 for x and 24 for y. And that would give you 24 is a times 1/16. And if we multiplied both sides by 16, make sure that that's pictures out of the way. If we multiplied both sides by 16, we'll have that 384 again. Okay, chapter 1. So that was it for our prerequisite section. Now let's go on to chapter 1. We started off this idea of odd and even as being a pretty important concept in math. And that has to do with understanding the symmetry. And right away, what you can see is this graph very rapidly has this beautiful y-axis symmetry. Was watching football yesterday, so it looks like somebody's given a field goal sign. I got a nice set of symmetry here, and that makes it what we call even. Now, this one has pretty nice symmetry too. You can see there's a line of symmetry right here. However, that is not specifically on the y-axis, and it is certainly not having any kind of rotational symmetry. So that classifies itself as neither of the two. It's not odd, it's not even, it doesn't have any special symmetries. But this particular one right here is really nice because it has origin symmetry. And that was you could spin it around the origin. If you could put your pen right here and spin your paper 180 degrees, the two graphs would look exactly the same. And in that same way, every coordinate right here has a mirror image coordinate down here, where if you did something like I need to put on my glasses so I could see a little bit better, but a coordinate like, say, -6, 4, and I know it's not exactly -6, 4, but it's dang close, would be the same as +6 giving -4. And that's what makes it odd. And a very convenient thing is the origin starts with an O, as does odd. And I've always found that to be helpful. Okay. Now moving down to this next part. Now that's the portion where you just simply look at it. But down here analytically, what I need to do is I need to look at t of -x. And if I did that, I have 36 minus, let's fix that. I don't know what happened there. 36 minus -x² over -x plus 1, which is, hey, well, the first thing that happened right there, which is awesome, is that it came back, which is kind of what you want to have happen. Like over here, where a comma b means you also have -a comma b. That seems to have happened, but unfortunately the denominator didn't come back. It came to a totally different answer than the original, and it's not the opposite of the original either, because I can't factor a negative out, because then this would be a -1. So this is a neither. It doesn't have any symmetry, but over here, b of -x, on the other hand, as soon as we replace x with -x, we end up with the numerator coming right back to where we started with, because you have 2 negatives here and 4 negatives there. But the denominator is entirely the opposite of where we started. And you know what? A positive divided by a negative is still a negative. So we could factor a negative out of the denominator, and that means the opposite of the original, and that makes it odd. So this is definitely an odd function. So remember, an even one is one where, let me put it over here, that f of -x is the same as f of x itself. It comes out exactly the same. And this one over here, the odd, is where f of -x is f of x with a negative in front. So changing the x results in changing the y. Changing the x here does absolutely nothing. Now, moving on a little further, this is asking us to look at a little bit about domain and range on the rest of this stuff. So, or I guess a composite to start with. So we want to start with b of -1. So if we did b of -1, I'm supposed to go up here into the original problem, and everywhere I see an x, I want to replace that x with a -1. And that gives me a 1, a 2, and a 1 on top, and a -1 and a -1 on the bottom. So it looks like I've got 4 over -2. So it looks like my answer is -2. Now I am going fairly quickly, so forgive me if I've made a small mistake in there, but I think we did okay. Now, t of x over here doing the domain, one of the things that we want to see in both of these problems, because they're very, very similar problems, is we really want to make sure that we're not dividing by 0, and we're also not taking the square roots of negatives. So in this particular question, where I'm looking at t, I really do not want x to be -1. That would be a problem for me, because I would be dividing by 0. But equivalently, I would like to make sure that I do not take a square root of a negative number, or I would have an imaginary. And if x gets to the point of either 6 or -6, that result inside would be 0. And it's okay to take the square root of 0, but of course 0 is right next to being negative, and that's a problem. So if we tried a number higher than 6, like 7 or 10, if I plugged in any number bigger than 6, I'm going to end up with a square root of a negative, and I don't want that. And similarly, if I went below -6, like -15, I would also have a negative under that root, and I can't be there. And so actually, these numbers right in here are actually okay. The fact that, lately in our course, we've been talking about the fact that this guy is positive and this guy is negative is really not really necessary, because really domain is just, can I get a real answer? And the answer is I can get a real answer anywhere from -6 to -1 and from -1 to +6. That would be my domain. Kind of harping on that same idea, we clearly again have the idea that -8 is where the top hits 0, and that's actually okay. I can take the square root of 0, but if I go below -8, I get those imaginary values, and I'm okay to go this way until I reach -1, because at -1 I divide by 0. But I can plug in any number that I want that's bigger than -8. This is positive, and the only problem I have in the denominator is that. So it looks like I can have anything that I want for domain-wise from -8 to -1, and then everything else from -1 to infinity. And really, this problem is almost a perfect rendition of the previous one, but let's just double check. I would first start by factoring the numerator out here a little bit, x minus 4x plus 3. I'd identify where those issues are, which I guess +4, -3, and -10 are all of my interesting values. And although I know 4 is okay, -3 is okay, -10 is certainly not okay. And if I go above 4, like 5. I know everybody likes to say 5. I would get a positive here and a positive here, and I can take the square root of those positives all day long. But if I picked a number in here, like say 0, I would get the square root of -4 times +3. That's -12. I cannot do that. That would be the square root of a negative. But as I proceed out here, the trouble is fine. It's okay. The fact that these numbers exist is perfectly fine in here. It's just I can't get anything in here because these would be my imaginaries. So this one has a little harder domain to write. I have everything up until -10, which of course should be an open bracket because it is where division by 0 happens. And then I have everything from -10 until -3, which even though I put an open circle, I'm just literally telling you that's where the answer is 0. That is the root of the equation. And then everything else from 4 to infinity. Okay, that's page 2. I think we got her done. Okay, I'll see you back in class. Hopefully that's helpful.